Hey, welcome back to Mr. Pelps with Precal. This is Unit 6, Topic 1, Lesson 1. We're going to start off with just the fundamental counting principle. Fundamental counting principle states, it's when you're trying to find out how many possible outcomes there are, and you really just take the amount of outcomes there are for each of the choices and multiply them by each other. For example, in this first question, a men's department store is going to sell you 3 different types of jackets, and then you're going to multiply it by 6 different shirts, and then 8 different ties and 4 different pair of pants. And then if you multiply all of those by each other, you're going to get 576 possible ways to have those combinations, which is a lot. How many 4-digit odd numbers can be formed if no digits can be repeated? Now, 4 digits. Well, first of all, the fact that it's an odd digit, an odd number, means I'm going to start at the end because only the last digit matters when it comes to figuring out if it's odd or not. So it could be odd if it has a 1, 3, 5, 7, or 9. So that's 5 different ways that can possibly occur. Now, it also says that no digit can be repeated. Now, if I go backwards, that means that one odd number has already been used, which means that there's now 9 different possible outcomes for this digit. Now, you might be wondering, why 9? Because remember, you can get a 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 outcomes. Plus, you can also get a 0. 0 is also a 1-digit number as well. So there was 10 possible numbers to choose, but you got to take away that one odd number. We don't know what the odd number is. It doesn't really matter, because once you take that one odd number away, you get 9 choices left over. Now, you might have guessed what's going to happen here. Now, if we've already picked 2 numbers, then there's only 8 choices for the second digit and 7 choices for the third digit. All right, so then 7 times 8, and keep in mind order doesn't matter, multiplication, commutative property of multiplication. You can multiply these in any way you want. So 2,520 different ways that can occur. Okay, so these questions get a little bit more complex, but the basis of it is pretty much the exact same. Just multiply the amount of outcomes of each event, and then your total in the end is the total possibility of the entire outcome occurring. How many 301 digit numbers are available if you can repeat the 0 through 9? Okay, so 301 and then blank 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 dash blank blank blank. It says that you can repeat the digits. So there's 10 different numbers as we talked about before. So you're just going to simply multiply by 10s all the way across. Well, 10, 100,000, 10,000, 100,000, 1 million. Or you could just say 6 zeros. 1, 2, 3, 4, 5, 6. Wait a second. I didn't do that right. There should be a 4th digit here because phone numbers have 7 digits. So this is going to be 10 million outcomes. How many 301 numbers is there if you cannot repeat? Okay, so there might be 10 digits on the first, but then there's only 9, and then there's only 8, and then 7, 6, 5, and 4. Okay, so 10 times 9 times 8 times 7 times 6 times 5 times 4. That gives us 604,000. That is a significant difference. And 800. That's not even 1 million, and this one had 10 million outcomes. So just taking away that repeating made it a lot less outcomes. How many 301 numbers are available if the first digit cannot be a 1 or 0 and the other digits can repeat? Okay, so the first digit can't be a 1 or a 0, so it only has 8 outcomes. If the other digits cannot repeat. Oh, okay, so what if, 2 different questions. What if the other ones can repeat? Well, that's just going to be 10 times 10 times 10 times 10 times 10 times 10. Actually, I don't even need to show that. That's going to be 1 million, and then times 8 is going to be 8 million. But what if they cannot repeat? Well, it's going to be kind of the same thing as this, only instead of times 10, it's going to be times 8 times 9 times 8 times 7 times 6 times 5 times 4. So 8 times 9 times 8 times 7 times 6 times 5 times 4 equals 483,840. All right, so that's significantly less than the 8 million there. And multiplication. So if an event S1 has R1 amount of outcomes and the event S2 has R2 amount of outcomes, to find the total of outcomes, you just simply multiply it. So that's R1 times R2. So you just multiply the amount of outcomes by each other. So for example, if there's just like the warm-up that I had, so 8 pants and 6 shirts, how many different outfits can she make? 6 times 8 is 48 outfits. And it's that simple. And count the number of ways each procedure can be done. So line up 3 people for photography. So you can there's 3 different people you can put first. And then once you've picked that one person, there's only 2 people left. And then once you pick the first 2 people, there's only 1 person left. So there's only one way you can do that at the end. So that means there's 6 different ways to line up those 3 people. So if you call them A, B, and C, you could put A in the front and then BC, or you could switch BC around. You can test this. There are still 6 outcomes. Those are just 2 of them. So basically anybody can be in the front, and then there's 2 more outcomes. Prioritize 4 pending jobs from most to least. Okay, so this is the same kind of, so there's 4 different jobs you can pick for the most important. And then once you've picked that, there's only 3 outcomes, and then 2, and then 1. So 4 times 3 is 12, times 2 is 24 different ways. Arrange 5 books from left to right. So there's 5 books when you pick the first one, then 4, then 3, then 2, then 1. That's going to be 20 times 3 is 60, times 2 is 120 ways. Award ribbons for first place to 6th place to the top 6 dogs in show. So 6 times 5 times 4 times 3 times 2 times 1. Multiply that. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. And there you go. So this brings us to the idea of factorials. And now I'm going to make a separate video for permutations and combinations. So in this case, factorial, which is what we were basically just doing here a second ago, this exclamation point right here just means 5 times 4 times 3 times 2 times 1. So 5 factorial happens to be, what's that, 20 times 3 is 60, happens to be 120. So this would be 4 times 3 times 2 times 1, which is 12 times 2 is 24. 3 times 2 times 1. So basically, factorial just means multiply it by all of its whole numbers that are below it, or actually all of its natural numbers, technically. Don't want to multiply by 0. 3 times 2 times 1, which is 6. This is 2 times 1, which is 2, and this is just 1, which is 1. Now, 0 factorial, you're going to find this is kind of debatable on the internet, but if you put it in the calculator, I'm just going to do that now, clear that out, 0, and then I go to math. Factorial is if you go all the way over to PRB for probability, which is what we're doing, and then go down to number 4, you'll see the factorial button. Now, I'm going to stay with the answer, which happens to be on the calculator, which is 1, but higher level maths will prove otherwise, but we're going to stick to the answer that the calculator has given us for the time being. So, factorials actually become very important because they are in the formula for both permutations and combinations, which is the reason why I wanted to lead ourselves up to this, which you'll see, which is basically what you're doing in the fundamental counting principles. So you're taking multiple items and you're arranging them in order, which you'll see is if the order does matter, then it's a permutation. All right, thanks again for watching. Please give a like to help you learn something about fundamental accounting principle and the basics of this probability and factorials. Thanks again for watching. Have a great day.